Alright, welcome back. So, increase in severity. Sometimes thunderstorms, if they're powerful enough, will spawn tornadoes. Or, like they say it where I'm from, tornadoes. Usually spawned by severe thunderstorms. They kind of go hand in hand. But severe thunderstorms. They are one of nature's most violent natural processes. They don't really compare, though, to the next one we'll talk about in the next video, but let's stay focused on tornadoes. They're classified according to the most intense damage that they produce. Not how big they are, how wide they are, but the damage that they produce, which is tied to how fast the winds they produce are. But you can infer that based on the damage you see. Almost like the Mercalli scale. You can put a value, an intensity on the earthquake based on the damage that you see, what you feel. Same thing here. But with a tornado, they used the EF scale, called the Enhanced Fujita scale. More on that in just a second. So, how do we get a tornado? Well, first off, different parts of the atmosphere, if you go up in elevation, the wind actually can be blowing in different directions. I encountered this, I've ridden in a couple hot air balloons, whereas at lower elevations, the wind might be pushing you one direction. But the way you steer a hot air balloon is you got to figure out which direction the wind's going. But you got to go up or down and let the wind blow you in certain directions based on where it's blowing. Because again, the further you go up in elevation, you're not influenced by the ground, by mountains, by buildings. So the wind patterns can actually, or the wind direction can actually be different the higher or lower you go in elevation. Well, first off, that's key in creating a tornado or tornado. Not only with direction, but the speed of the wind. Closer to the ground, the wind's going to move a little bit slower. It encounters the ground, it encounters buildings, it encounters hills, it encounters a number of things to kind of slow it down. Whereas the further up you go into the sky, there's nothing to kind of impede the wind so it can move faster and faster and faster. And so that's what this kind of shows you. It illustrates that near the ground, wind is generally moving a little bit slower. Further up, wind is generally moving a little bit faster. There's also some directional change, but this is in general true. So what happens is you get air moving faster here and slower closer to the surface, which creates this tumbling effect of the air. This rotational tumbling. Maybe you can see where I'm going with this. So, you get the faster winds above, slower winds near the ground, creating this tumbling, this horizontal tumbling. If there's one of those kind of updrafts where hot air and cold air meet and that air is kind of being pushed upwards, well, if that tumbling air encounters that, what's called an updraft, so if that tumbling air encounters that warm air rising, well, that thing gets sucked up. So that tumbling mass of air gets kind of pulled up, and now it's not rotating horizontally. As it's getting pulled up, now it's rotating kind of vertically like this. And guess what you just made? You just made a tornado. So that's kind of how it works. It's a little bit more complicated than that. They are rare for the most part, but they do occur, including in Arizona. So again, the EF Enhanced Fujita scale, it's an intensity scale, so it relates the damage done from light damage, some chimneys broken, branches broken off trees, smaller trees kind of pushed over, signs damaged, to incredible damage, strong frame houses just leveled off their foundations, trees debarked, so ripped, the bark just ripped off the trees. Automobile-sized missiles are flying through the air in excess of 100 meters, over 110 yards. So cars are just thrown, a whole football field, a whole soccer field, a whole soccer pitch. So, but again, that happens the faster the air is moving, the faster the wind is. But the wind estimate it's just that, an estimate based on the damage. So that's kind of how that's worked out. Just a little, what you might see, some light damage. And as we get into, EF2, we're talking about your roof being blown off. EF3, your car, flipped over, trees falling, house destroyed. EF4 and 5, there goes your car flying through the air, there goes your house, etc., etc., etc. So, where in the U.S. gets the most tornadoes or tornadoes? Do you know? Think about it. Maybe you've seen the movie Twister. A lot of places get them. Where in the U.S. gets the most? It's a place called Tornado Alley, right? And it happens in kind of the central U.S. Remember, Florida gets a lot of thunderstorms, so they do get a decent amount of annual tornado incidences on average. You need severe thunderstorms to create tornadoes. So Florida does get some, but the highest percentage really occurs in the kind of central plain states, area called Tornado Alley. Here's Arizona. Look, guess what? We also get a half to one tornado yearly on average. So once, you get one every 2 years on average in central Arizona. That includes the Phoenix area. Fun stuff. More on that in lab. So in any case, but yeah, this central area is, where they're going to get upwards of more than the 9 a year. So 10 or more than 9. So 10 or more tornadoes a year on average. So that area exists in Tornado Alley, which extends from Texas up in Oklahoma, Kansas, Nebraska, South Dakota, a little bit in Colorado, Wyoming, into Iowa, Minnesota, a little bit into Missouri. So again, this is the area known as Tornado Alley. Tornadoes occur in other places, and I'll show you where, but this is where the biggest and the most common have been historically. With climate change, it's starting to change a little bit. So what do we get? We get warm, moist air. We get cold, dry air. We also get some warm, dry air mixing with the warm, moist air, so double warm air, and then kind of pushed up by cold, dry air, creating intense thunderstorms and possibly spawning tornadoes. So again, it gets a little complicated, but that's the basis of it. You get warm air and cold air mixing, and that tends to happen right in Tornado Alley. You get this warm, moist air coming up from the Gulf, cold, dry air coming down from the central northern states. They mix, severe thunderstorms. Those thunderstorms could spawn tornadoes. The reason also you're going to have more tornadoes here is the terrain, very flat terrain. So remember that rolling, that tumbling of air? Well, that can happen here. There's not a lot of stuff out there. You get this flat terrain, so this faster air above, slower air below. You get this tumbling happening, and if that tumbling kind of just coincides with these air masses meeting, and that tumbling air can get pulled upwards, pulled vertically, now you got a tornado. But here, again, very flat, no mountains, no hills, no nothing. If you've ever gone through or visited the central U.S., there ain't much there. And then you get, again, these three contrasting air masses to really create this uplift, this atmospheric instability, and that they all merge kind of here. Now that's historically. What I'm about to show you is a map so far of this year of the tornado watches outlined. Now, this is going to look a little weird, all right, because most tornadoes happen here, all right, Tornado Alley, for the most part. But look, most tornado watches where people have been warned for tornadoes happen in the south. Do you know why that is? Because not a lot of people live here. So they get a lot of tornadoes, but oftentimes they're just tornadoes in the middle of nowhere. If no one's there, there's no issue. Well, here's more highly populated, more densely populated, a bunch of cities kind of packed in. Here, cities are very spread out, a lot of large farms, and not a lot of issue. So that's why you see the more intense red happening here, that more tornado issues are broadcast in this area, telling people to watch out for tornadoes. Not that they get more, but since there's more people there, more chance that a tornado might encounter an area where it's populated. Central U.S., not so much. But again, you can see, for the most part, tornadoes or warnings are really only issued kind of in the central and southeastern U.S. Some up into the northern and eastern portions, but more central and southeastern. Same thing with last year. You can see Tornado Alley, actually not a lot going on. Not a lot going on there as far as tornado watches. That could be climate change driven. You see a lot more tornado watches, here. Not that they're not getting them, it's just, sometimes it's just the fact that there's not people there, so you don't have to issue a warning if there's a tornado in a place where no one lives. But looks like things are changing a little bit. So far this year, this map looks at fatalities. There's been 13 fatalities associated with tornadoes, 7 of them in Alabama, 3 in North Carolina, 1 in Louisiana, 1 in Pennsylvania near Philadelphia, and 1 in Texas. And what I want you to notice as far as where these fatalities occur, 7 of those have occurred in manufactured homes, mobile homes. 5 in regular homes, 1 unknown. So that's so far this year. Last year there were 78 fatalities, 28 in Tennessee, 13 in Mississippi, and you can see the rest. And again, by circumstance, where were these people located? The vast majority, mobile homes. You know, there's kind of a joke about tornadoes and ripping up trailer parks and mobile homes. Well, it's a very real issue. The reason being, mobile homes, manufactured homes, they're just very cheaply made. They're very light frames with some aluminum skin on the outside, some wood as well. But you apply a little wind to that, and those things tumble. They break apart. The glass breaks. The aluminum turns to razor blades and just slices and cuts people. So it's just dangerous to be in. And they don't have a sturdy foundation, so they can again tumble as well. So. And that was last year, 78 deaths. 2 years ago, 41 deaths, a lot in Alabama. Again, manufactured homes. So a lot of deaths occurring, again, in the southeast. Why? Because it's just more people, more densely populated. A tornado going through these areas is going to encounter much more cities, much more homes than a tornado going through the middle of Kansas. There ain't nothing in the middle of Kansas. I'm sure you've seen tornadoes. They come in all shapes and sizes. There's people out there that call themselves storm chasers that chase tornadoes and take videos and take pictures of them. Maybe you've seen some of these things on YouTube. Not the brightest of ideas, but that's what some people do. So in any case, tornadoes. We're going to pause there. When we come back, we're going to take it kind of one step up. Not related necessarily to how thunderstorms or tornadoes form, but we're going to kind of take a step up in intensity and energy and carnage and damage when we talk about the next severe weather when we come back. See you in a second.